Welcome to our last lesson for Module 13. We're going to look at the discriminant today. So I can use the discriminant to determine the number of solutions to a quadratic equation. If you remember from back in the graphing section, we had times when the parabola never crossed the x-axis, in which case we had no real solutions. We had times where it just touched the x-axis, which gave us one solution. And we had times where it crossed twice. And that happens a lot. But when it crosses twice, you have two real solutions. Is there a way to look at that without actually graphing? Yes, there is. There's a formula called the discriminant. It's used to find out the number of real solutions to a quadratic equation. And it's done without graphing or solving. So you don't have to do it all the way through the solving process. You just have to use this thing called the discriminant. Now, the discriminant is b squared minus 4ac. That's the formula. Now, that should look familiar to you. If you've been paying attention to the first two lessons of this week, you've seen that expression inside the radical in the quadratic formula. And yes, it is tied to that. Okay, so again, a, b, and c come from standard form. The equation must be equal to 0 still, just like it did in the quadratic formula. So here's what happens with the discriminant. If the discriminant is greater than 0, so when I plug numbers in for b, a, and c, if the answer when I type that in my calculator is bigger than 0, it means there are two real solutions. They could be rational or they could be irrational, but there's two. It will cross the x-axis twice. If the discriminant or the number that I get when I plug it in the calculator is negative, that means there are no real solutions. And if the discriminant is exactly 0, there's only one real solution. Now, one thing I want you to note, the number that you get is not the solution. A lot of people get that confused. They plug a number in and they think, oh, there's my answer. It's not the case. Okay. It's telling me the number of real solutions. So you're either going to have 2, none, or 1. That's it. That's all you can get from the discriminant. All right. So number of real solutions to a quadratic equation. If d is less than 0, the discriminant is less than 0. That means there's a negative number under the radical. You should know what that means by now. That means that there's no real solutions, and that means the quadratic or the parabola will not cross the x-axis. If it's equal to 0, that means there's a 0 under the radical. So you're going to be, in the quadratic formula, you're going to have negative b plus or minus 0. Well, if you add 0 and you subtract 0, you didn't really go anywhere, so you're going to get one solution. If it's positive, squared up of a positive number, you're going to get two solutions. So let's go ahead and do an example. First thing I'm going to do is get it equal to 0. So I'm going to subtract 7. A is 3. B is 12. C is negative 7. So plug them in. Make sure you're using parentheses still. Again, reminder, if it's bigger than 0, if the number we get is bigger than 0, it's two solutions. If it's less than 0, there's no solutions. If it's equal to 0, there's one solution. So let's plug them in. So 12 goes in for B. A is 3, C is negative 7. When you type that in your calculator, you should get 228. That's a positive number. So that means it's going to have two real solutions. It is not the solution. D equals 228 is not the solution. What it is the number under the radical. So there's still more to do if I want to find what the solutions are, but I know without a doubt that there are two solutions. Okay. Does this equation have a solution? If yes, how many? So first thing I want to do is add 7. 8 plus 7 is 15. Now I'm equal to 0. We're going to use the discriminant. Little reminder. A is 2, B is 8, C is 15. Plug them in. 8 squared minus 4 times 2 times 15. If you plug it in, you should get negative 56. That's a negative number under the radical, which means this will have no real solutions. Again, this is not one of the solutions. A couple applications. Okay, given the equation, sometimes and with these applications, you're going to be given the equation, but you're going to have to plug in some numbers. That's what you're going to be doing with this discriminant. Now, we're going to use the discriminant when you have a yes or no type question, such as, will this situation happen? I'm going to give you one of those situations next. Suppose Brady kicks a football and gives it an initial upward velocity, which we're going to call v, of 54 feet per second. The starting height of the football is 3 feet, and s is the starting height. The equation for the height of the ball at any time during the path is given by that equation there, where t is time in seconds. A lot of variables there, but we can fill in a lot of those variables. Okay, the question is, will the ball reach a height of 20 feet? So that's a yes or no question. All right, so you've got a picture of what's going on here. Two different paths, two different kicks. So will this equation have solutions if the height is 20 feet? This is a yes or no question. So we use the discriminant. How? We're going to use that equation there. We know that the height is 20 feet. That's a h value, so it goes in for h. Negative 16t squared. V was 54. That was given to us in the problem. And the starting height was 3 feet. Now, we can't go straight to the discriminant because it's not equal to 0. So I'm going to subtract 20. 3 minus 20 is negative 17. Now I can go to the discriminant, plug in the numbers, and then put it in my calculator, and I should get 1,828. What does that mean? It means that's a positive number. It means there are two real solutions, which means the ball will reach a height of 20 feet. It's actually going to reach 20 feet twice, once on the way up and then once on the way down. Okay, so that's an application of the discriminant. Answers how many solutions a quadratic has. And that concludes lesson 3.